Hey everyone, my name is Brad, and you are seeing, you are seeing a login. Hold on. This is what my cohort referred to as the NASCAR of maps. But it actually does a pretty. By the way, I'm Brad. I work for NBC News. Great introduction. So maps. First, I want to talk about like why maps. Like it's more than just for directions and just seeing where people voted, and it's really a great tool for storytelling. So that's kind of the thing I want to sort of convey first. This map it's interesting. I mean, it seems a little maybe archaic and cheesy, but it does a really good job of telling a story of where these companies kind of are based out of, right? And so this is from Steve Lovelace. This is quite a while ago, but I think they update this every year or so. So this is the corporate states of America. So yeah, like I said, I want to talk about why we want maps, different mapping solutions, and maybe get into some ideas on how we can use maps. So we'll get into that. So this is a cartogram. So this is a map on which statistical information is shown in a diagrammatic form, right? So it's taking the map of the world and also combining world population to have this kind of disfigured shape to it. But it also helps kind of point out, where the populations are with still keeping that reference of, oh yeah, I know what country this is without even looking at. It's a much better representation than just a list of populations that you would see on Wikipedia. It gives you a really quick glance of what's going on. So here's another map, a map we recently, maybe a month or two ago, released our Battleground map. So this is this is showing, the Democrat, Republican side of things, and also where there's a closer contest, right? So maybe I take for granted that everyone knows what the Battleground map is, but this is something that we have up on our site and helps kind of help describe that what's going on with the election. But there's one thing missing with this, and anybody want to guess what is not quite there? Like what part of data? I'm leaving myself hanging here, but I'll give you the answer this time. The next one is on you. Electoral votes, right? So this doesn't give you a good representation of electoral, like which states are actually the most important, or not important, but which states are weighted heavier in the election due to our electoral college system. So in comes the Battleground map cartogram. So this now adds in, much like the other cartogram, this adds in that idea of electoral votes. So it's a little weird to look at, but you do get an idea of kind of that it is a map, and you can quickly glance and see which states, and you see a big difference there's a lot more red here than kind of here. I mean, it's definitely, this is actually an old Battleground map, sorry. But you can definitely feel a slight difference on the amount of blue versus red. And the source for this was actually New York Times. This is another style of cartogram. I guess it's a cartogram grid. So it's a little small here, but you can definitely see how battlegrounds have shifted over the years. That's what this is trying to explain. And it goes back from 1976 to 2012 to show where the battlegrounds have been over the years. Another way of looking at, yeah. You guys hear me all right? All right. So here we have maybe not quite a map, but this is a Voronoi diagram. Does anyone know the correct pronunciation? No? Is that good? Okay. It is good? All right. Are you Ukrainian by any chance? No? Okay. Yeah, right. So I didn't know if it was Voronoi, but anyway, I won't get into that. So the Voronoi diagram is a is a great element or possibly an overlay to a map. So the Voronoi encodes proximity information that can help you answer questions. So the one on the left is a Voronoi I created with a library called D3 node. So it's basically created with D3. It's actually pretty straightforward. It's using just random points on a canvas or on the canvas. On the right, you actually have a pretty famous Voronoi that actually is from 1854. So this is not like new technology. I mean, actually the math for this has been around since like the 1600s, which is kind of interesting. But this was famously used by Jon Snow. I'm sorry, what is the HBO show? Game of Thrones, yes. Sorry, I don't watch it, but so Jon Snow actually used this to try to I was during like the Great Stink and all these things going on in London where there was a cholera outbreak at that time, and he was trying to prove that it was this. So this pump, represents a water pump. So he was trying to, show the city that all of the deaths were around this one pump, and he actually no one wanted to believe it. It was actually many years later that they actually went back after he was dead. Actually, he actually was vindicated, and they're like, "Oh yeah, this is the problem." It was basically fecal matter dripping, getting into the. Anyways, sorry, I don't want to. Sorry if I go there, but you can read about it. It's really interesting. So it's also used in urban planning. So if you want to figure out where to put the next police station or where the nearest hospital is, these are pretty helpful things. So yeah, I'll probably get back to this when I do another demo. So, so that was my attempt of hopefully describing the problem that we were trying to solve around storytelling with geospatial data. So getting into the solutions, there's a lot of different ways to do this, but one path that I've gone down is using a couple different technologies that are somewhat standards for the web, really. So anyone want to guess with either of these maps what they're maps of? Anyone? I heard someone say railroads. Yes. You win a free ticket to the next meetup. Give that guy a ticket. Or that woman, sorry. Yeah, there you go. So the one on the left is the railway system, and the one on the right, anyone? Okay, it's airports, yes, cool. So there's this project that actually the creator of D3, how many here know D3, have used it? Just a few, okay, good amount, cool. So Mike Bostock, he created this this U.S. Atlas, among many other things. Created U.S. Atlas. It's really just it's a GitHub repo you can pull down and run some shell scripts. And what it does is it essentially pulls down the shape files from different organizations, mostly from the U.S. Census Bureau, a few others. But it's a really great thing to just look at and see where you get these files from, and you can run these commands whenever you need to. They do update on occasion. Maps aren't even though we think of maps as like borders don't change, right? But redistricting, counties change, especially when it gets pretty complicated. Like when you look at all the different geospatial data around the world, like just stuff changes all the time. And also, there's data within these map files, these Geo JSON files, like FIPS codes and things that identify these geographies. So, anyways, what I want to get at is you've got these. What you typically get from the census type of organizations is a shape file, right? So that's a binary file that it's really hard to use for the web, pretty much impossible to use. It's a binary encoded file. It's not human readable. It actually has some other limitations, storage limits and things like that. But So that's why the Geo JSON, everyone here loves JSON, right? Spend half your life probably reading through it as programmers. But so Geo JSON was really the first kind of standard. It actually, only a couple weeks ago, became an IETF standard. That's interesting. It took, I think, a long time for that to become a standard. But the files that you get from Geo JSON are kind of, they're very vague, I would say, and very verbose at the same time. So maybe the better word is like abstract. Like everything is within this thing called a feature collection. I don't want to kill the definition of a Geo JSON, but there was another kind of version of that, or a subset of Geo JSON called Topo JSON, which is also created by the author of D3. And you can kind of tell why. So having this other format that works well with D3 on the web, it creates, it's an extension of Geo JSON, but it produces the much smaller JSON files. And it also simplifies. If you ever look at a Geo JSON file, you see a huge array of coordinates, like Latin long coordinates. But Topo JSON converts them or encodes them into something called arcs. It's a great library. At least as far as the US Atlas kind of leverages Topo JSON, but I think I'll get more into that. So like I said, Geo JSON is the standard through the IETF. So this is basically how you could download a shapefile. So there's a package or library called GDAL, which you have to have if you're getting into like this map making stuff. It's super powerful and does all kinds of things. But so once you get GDAL installed, you can pull down the US Atlas repo. You npm install, and then you run a make script, which, for instance, this one would pull down the New York counties. So now that you have this shapefile locally, you're kind of like 1/3 of the way there. Now you can use GDAL, which has a tool called OGR to OGR. And you say, use the format Geo JSON, and you convert that, the shapefile into the Geo JSON file. So Geo JSON you can use with D3. Like I said, it's comprised of these feature collections, which you can work with that in D3. But there's a few other reasons why you'd want to use something like Topo JSON. So there's some good stuff. The Geo JSON spec kind of goes through what it is and what it isn't. So I suggest checking that out. There's also the GDAL documentation is not great. It's actually really needs to be updated, but there's some good. A lot of people are using it, so there's some good resources out there, especially this GDAL cheat sheet that I found. So let me see if I can open this tool. What's going on here? I'll get back to that. We'll go through this. There's a tool called Map Shaper. So if you're kind of like in this state where you've like downloaded the shapefile and you want to test it out, you can go to mapshaper.com and actually upload it and see how it's, you can see some of the data some of the metadata that are in the geometries, and you can kind of inspect and see what's going on and see if it's like the right map that you're looking for. Because there are so many different, just for like the state of New York, there's district maps, county maps, town maps, you name it. So it's a great, Map Shaper is a great tool for that. Are you guys liking this scrolly, like over slides? I think I'm kind of liking it, I don't know. Yeah, it's just like scrolling, it just feels a lot freer. You just go down and up. Anyways, that's my. So now, if we want to get into creating some Topo JSON, which is where all the magic happens, in my opinion, you don't have to mess with Geo JSON. You can go right from shapefiles to Topo JSON, and I think one thing you'll probably figure out is that I think Topo JSON is a bit more opinionated, but it kind of makes more sense because you can have multiple like collections within there, within each file, and it's obviously much smaller, so it's not going to like crash your text editor if you actually want to like look at it locally. So it's just so much easier to work with. Props to Mike Bostock, because these are all like super, every single tool I come across that is super like helpful for doing maps, I find out that somehow Mike Bostock was involved, so, or actually created it. So, here's some commands. I won't go through it. It's kind of similar. You know, you make the shape file and then you convert it. There's some really fun kind of CLI API to this. Won't go through every piece of it, but you'll see this is a simplification, this -s. That's an argument for a simplification algorithm. I think it's an algorithm, but it's basically, there's all these different sets that you can set to simplify this file. And there's also a quantization, sorry. These are all fun, like new, fairly new like terms that I'm getting up to speed on and using, but it's like, it's super interesting stuff. So yeah, Topo JSON spec and linked up in here, and here's MapShaper again. Can't get enough of that. Yeah, so let's look at a quick map rendering using D3. So this example is obviously, is definitely a client-side example. So yeah, it's actually pulled from blocks.org. Anyone familiar with blocks? Awesome site if you're doing anything D3. I know you are. There's actually a really cool site that actually Sam, my coworker, showed me. It's a block builder. Like the amount of stuff on there is amazing. If you want to do D3, like all this stuff, all these different examples, I completely stole from blocks. I mean, like I would never be able to figure out how to do a Voronoi diagram, let's be honest. But you know, the resources there are pretty amazing. So this is a really basic one that just renders the US map. You can see, you know, here's this first line. It basically, all it's doing is creating an SVG. You can create maps in like a canvas element, but really SVG is really the way to go just because you can, it's kind of like portable and it's sort of, you know, all the examples that you'll see are always using SVG. So that's really what we're creating here. We're creating an SVG and then we're manipulating it. So step 2, you're fetching that Topo JSON. So this file here is obviously the Topo JSON for the US, which has all your geometries for the land and also for every individual state. And you can see that's what step 3 does. That sets the bounds for the entire map. I believe it also deals with positioning like Alaska and Hawaii. There may be some other tricks. No, yeah, that's included in that. So last step is you're setting your topology for each state. So as you can see, it's setting a path and then using topo.json.mesh to then basically set the arcs on each of the paths in your SVG. And also we're doing some stuff where we're setting a class on each path, right? So that we can sort of style like the fill. This is where you can actually do some interesting stuff, like let's say you want to set like some properties on each path, like you want to put in the population for the state or electoral votes or whatever. That's where you can, pulling from another data source, you could, you know, package in that metadata for each geometry. So, yeah. Yeah, you got a question? Yeah, so do I not have a projection on here? Yeah, so I think that's one of the things that Topo JSONs can help out with you. You can actually bake in the projections. So this file you don't need it. So it's kind of one of the nice parts. But yeah, like Albers USA is like your typical projection. There's all kinds of pretty interesting projections that you can. So a projection is basically how you transform. I think the definition is transforming one point to another, but yeah, it's kind of a hard to really explain. But sorry.
Would it like group all of points in one state into like the center of that state?
I don't think you would do that with a projection per se, but let's say you wanted to make, like you could add a projection like a world, like a globe, like a Mercator projection, I think it's called, where this would look more like a kind of like a non-flat surface, right? So that stuff, if you're trying to do that like freehand or something, like it's impossible. Like I don't even know how you'd start like doing that math, where literally in D3 you can just apply the projection and it will change the map based on that, if your Topo JSON kind of is set up the way you need to. So yeah. So going back to what I was saying earlier about embedding data, here's a way with the Topo JSON CLI that you can actually do that. This is a nice trick. I had some issues with it. So I typically do this type of stuff. This is one of the reasons why I think we started doing like some of the stuff server side, kind of like joining data with a Geo JSON file, is because I could do it pretty quickly in Node. Where with the command line tool, it's nice, but then like obviously that's not going to work when it's like the data's changing. But this technique is pretty nice, where you can take a CSV file, or in this case, yeah. So this is a population file, right, for Kentucky, and you can basically say, okay, the property I want to join on is FIPS, right? And and the -p means these are the fields I want to include, and then you basically output, or sorry, the -e is your input file, and you can output this to a shape or a JSON file. So this is super handy. But like I said, it's actually something that we're doing server side. So we're just taking the JSON file and kind of looping through and merging, or actually joining the data with the JSON file from some other external source. One example is on NBC News, we have election pages. For each state election in the primary, we have 2 maps, for the Republican and Democratic primaries or caucuses. And so we're doing that on the fly. So we're hitting an API and then kind of doing this on the fly. And we haven't like totally killed our servers doing this. So it seems to work. Plus there's a lot of caching involved and things like that. But yeah. So any questions? Nope. So here's an interesting, this is basically the map I was just talking about. So this is the Iowa Democratic Caucus. So to give some context, like I was saying, a lot of this rendering has happened server side. So you can imagine like, okay, now how do I do like interaction events? Like how do I do certain things when I either hover or click or touch on a geometry? I think your typical example is like your tooltip. I think you probably see that on every like map kind of, on any type of map visualization like this. So there's a couple of ways. Even if you're doing it server side, it's pretty non-trivial to use jQuery or D3 even to basically select that map now server side that has all the data bound to it through the properties on each path, and that's exactly how we're doing this. I believe for this exact one we're actually using D3, but you could actually use, if jQuery is more of your thing, you could actually just create a little jQuery, select the map, and when someone click events on the paths, and show like a tooltip like this. So it's kind of nice because all the data is like packaged up into the SVG, which is embedded in the page. So it's pretty portable. One other thing, so these SVGs do rely on like other styles, but one thing we are are currently trying to do is like injecting styles into the SVG, so like they'll actually render exactly how they display, how we need them to display on their own, which really helps with like being able to embed these in other pages like articles or whatever, trying to render like images of them and stuff like that. That's actually one of the main advantages, because now you can use a tool like SVG to PNG and render it and basically create a PNG for your team to post it in social media, things like that. So this is another interesting part of maps, I think, is this coloring. Like I always thought, I sort of took this for granted, because I was like, oh wow, that's a really ugly color scheme, right? That's kind of like your impression, but there's actually, what do you know, there's like science behind it. There's a bunch of different reasons. I think, I'm not an expert on this, but Color Brew is a great resource. But being able to like create these different color schemes that are tested, like for disabilities, for color blindness and things like that, things that you're not gonna think of when you're just designing your own color scheme. Like, oh, I'm gonna make these counties like gray and make these purple. And it's just, you can just totally do it's easy to like mess this up. So using like tested color schemes is really helps you with your colorization of geometries. So sort of touched on some of this stuff, but like, so the server-side rendering of SVGs, like why would you want to do that? Well, I mean, the obvious things are, you can manipulate the data from, let's say you've got a really slow API, or you're pulling data from your own API, you're pulling data from AP, you're pulling data from, CDN to make this whole thing like visually happen. You don't want like for me, like I don't want every single user on our site to be doing that over and over. It just seems very inefficient, right? So offloading that stuff to the server makes a lot of sense. And D3 for me is like, I don't know a better way to really render maps server side. I know there's a lot of tools out there, but the amount of like control and flexibility you get with D3 is really kind of like the point. I think that makes the most sense. Plus, when you're doing things on the server, you don't have to worry about some quirks with browsers, and as long as you make that SVG, it's a scalable thing. As long as you make that thing work on different viewports, it's going to work. SVG's been around for a while. I know there's been issues in the past, but with every browser really supporting it, Microsoft. But they, it's really a no-brainer. I know Android in the past has also had its woes with very, very old versions of the Android web browser have had issues with it. And the other thing I like about it is really like making this kind of like a microservice. So being able to just have this one thing that does this really well. You send it like a D3 script almost. That's slightly modified for server-side rendering. You send it to JSON, your data, and you do your joins, and then it spits out an SVG. I think I kind of like that approach. So yeah, how to do that? So D3 Node is a package I open sourced, and it only has like 10 stars, so I appreciate any kind of like bump there. Hopefully I get like 2 after this, maybe. Anyone? Yeah. Okay. I think I just got 3. All right. So and it's a really simple wrapper. I kind of consider it like just like a helper, because it leverages JS DOM, which has gotten much better. I think the server-side DOM stuff is going to get more and more popular because of JS DOM. It's a lot more stable, especially on Node 4. I've used it in the past and had lots of problems with it, but it works pretty well. And then obviously D3. So JS DOM, D3, and D3 Node just has some like factory methods where you can say, instead of doing all that, append SVG, blah, 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 and like set the width and the height and like attach a namespace, there's just a method called create SVG. So it does all that for you every time. So, and the reason why I created that, it's optional, but the reason why that's there is because if you don't add like the namespace, which many of the examples actually that you get out there don't add a SVG namespace, so it it won't render as a PNG, right? So when you go to run it through a tool, it actually will break like most headless web browsers because WebKit can't necessarily render it, or Phantom.js can't render it. So, little tip: use D3 Node. So that's my shameless plug. Or no, wait, I have more shameless plugs. Sorry. So Cheerio is a basically server-side jQuery. So that's another tool that you can use with D3 Node. So basically when you're returning that, we use this for our Battleground map, which was, see. So there's like a legend and like this data up top. So every time we render that SVG, it actually comes from so we only render it once, we update, so we have our editorial staff, I should have probably touched on this earlier, but editorial staff updates a Google Doc. Maybe I shouldn't share this information, but they update a document somewhere that's in the cloud, and we run a task every time that is updated, and we can test it locally by rendering it locally, and then once we're kind of good, we push it up to our CDN, and our renders actually make a request to this this asset, but that asset, that SVG file, has data kind of packed into it. So when we get it from the CDN server side, we can actually inspect it with Cheerio and pull the data out, and then basically return that to the render, so like the template. So we're using Node, Express, handlebars, and things like that. So by doing that, it kind of gives us we're not only getting an SVG that's packaged and has all the stuff that we know it works, it's actually delivering data too. So that we can deliver to like the other templates on that page. So I thought that was an interesting little hack, and it seems to work. Where are we? Yeah, so the last pillar I would say is the top of JSON. That's super critical. Yep, so to continue my plug, here's the README for D3 Node. I kind of already touched on most of these things, but why? Because why not? Yeah, so I mentioned being able to embed style sheets into the SVGs, super helpful for that PNG output. Yeah, so I would definitely suggest, if you check this out, go right to the examples and you can run them all. I think I'm up to like maybe 6 or 7 examples. I've got the Voronoi diagram in there that you can play with, and you can just modify. There's a couple parameters like density, so you can change it. I think it's set to like 20 points. You can change it to however many you want. It's with just one variable. Pretty cool. And then you can actually feed like real data to it. That would be even cooler. So yeah. So this is where we get to the brainstorming of it. So I actually have anyone here from Shutterstock? I actually have a pitch for you. There you go. So I actually have a pitch for Shutterstock. This is how to kill it with real-time data cards. There's a couple publishers where kind of talking about data cards, but a service that you can feed it data like top of JSON, especially based around the elections, and maybe you guys are already working on something like this, but where editors and publishers could see election data, what's going on right now, and be able to create an SVG or a PNG and drop it into their CMS or drop it into their to whatever they're using. And also one of the problems is with SVGs is being able to have like easy access to, like obviously you can't share, social is a big part of it, so you can't share, like when you share an SVG, you need like a PNG render to go with that in order for it to look good when you share it on Facebook, right? I think there's a lot of things worth exploring there, and we're trying to explore that as well, and we're doing it, but I think there's a lot of publishers that would definitely be interested in that. And you could use D3 Node. So looking forward to the npm installs. Yeah. What else? Lots of cool stuff. Oh, we're working on a project. It's super top secret, so I'll just tell everyone here. Topo query. So this is, it's sort of, we're actually building it for a broadcast where we can just send broadcast a URL and they can pass different parameters in. So they can say, like, for example, this map, right? See how that specific county is highlighted? So we can actually, just with query parameters and some, some routes as well, be able to say, here's the URL, and they put it into a system called VizRT, which is kind of like the standard for these, the TV industry. And they can kind of manipulate it. They can like turn off the background shadow with just a couple query parameters. So that's in active development right now. Also being able to like load a certain state with different types of maps. There are tools out there. One is actually Quartz has one called Map Query. But yeah, we definitely need to be able to customize something for our needs. So let's see. Oh, so one of the things I want to mention was who here uses GitHub GIS a lot? So, okay, more hands over here. So blocks.org is built on GIS basically. So every block that you see on blocks.org, when you go to it, it's basically a GIS. There's like no back end to it. So one of the goals of D3 Node that I'm not quite there yet, I'm almost there, but I just need to do a little hackery, is to be able to just point to a gist and render it out as a static image or a static SVG. So that's one of my goals with it, because I think that'd be cool to have like that static render of every D3 visualization. Probably 50–60% of them won't look right because a lot of them are interaction based or they're animated, right? But there's a lot that actually could render nicely. Yeah, any questions? I think that's it. I think I got it. Any questions? Sorry, yeah, actually I didn't totally get the question. Was
Like with your D3 node library,
right.
what are the things that you had to do to make D3 like server-side ready?
Oh, right. So, I mean, the number one thing is that obviously there's no DOM, right? So that's the biggest thing, is really there's a few steps you have to set up in order to get JS DOM to like work well with it. So that's one thing, just being able to create the DOM in a simple way that doesn't, interfere with it. Just having like a clean API, so you can easily say, okay, so like creating a new instance of D3 Node, and then you pass in, you can pass in some HTML, so we call it like a container HTML. So, and then you can also pass in a selector, so that you can, when you inject the D3, you can actually have some like HTML around it, right? And the last piece is injecting styles. So that's actually pretty tricky. I think that was probably the nicest part about it, is there's a really easy way, like you can just give it some CSS and it'll inject that CSS into the style sheet. And I've been testing the heck out of it, and like all the examples, it works. So yeah, so it's not like there are plenty of examples out there where how to use D3 on the server, and it's like I don't know, like 100 lines to get it to work. So it's probably less than that, but and JS DOM has gone in through some changes that have made it easier. The other thing is that D3 is in this weird spot right now where D4 came out, and D3 version 4 came out, and version 4 basically breaks like 70% of that API. So all of the examples that were done in version 3 or sorry, all the examples, yeah, all the version 3 examples, you can't just like change it to version 4 and it's going to work. You have to basically like, it's kind of a bummer, but there's a lot of, I think, good reasons why they broke the API or made breaking changes to the API. But it's definitely a more modular approach. They got rid of they flattened out the namespacing, so there's some good things to it. But I mean, it was I think a bold move on D3 part to kind of like just say, yeah, we're just going to break all the old this huge amount of examples. Like they aren't really going to work with, they aren't going to work at all with D4. So. So my point on that was with D3 node, you can pass in pass in the reference or the library. So if you want to use D3 version 3 or version 4, you can just pass it in and it'll work. So yeah, sure.
So I worked on this with Brad a bit. So when you use D3 on it, like to manipulate SVG, it has data bound to any SVG elements that are created with D3, and it's bound in the prototype properties. It creates a good property on the prototype, so you can't pass something to the prototype from the server side to if you're rendering client side. So you're going to need to rebind your data to the SVG if you intend to use it in the D3 native way. That's not an issue if you're not having any kind of manipulation of the SVG, but that is one other thing. This is very good for rendering static assets. If you're going to do some really advanced transformations, you end up having to rebind the data before you use D3 to manipulate it. Yeah, is there any way to kind of block, take a rendered SVG, include some extra stuff in it, and do you want to, you want to pull up Battleground map and inspect and show the data that comes with it. This is the best part of this is you can bind data to SVGs using just HTML5 data attribute, and then once the data is bound to that SVG, you can use it in other ways. So that table on the side is actually rendered with data that's bound in the SVG. So yeah, you just go to the top of it.
Sorry.
Top of the SVG. Not physically, but
Hold on, it's just a little slow here. Sorry. Okay. Well, there's data here as well. Sorry. Oh, I gotcha.
yeah, right there. So you can see that if we were to scroll to the Battleground map, you would see there's an actual JSON object that's been rendered server-side to that SVG. And then we can take that same data and render other things with it. And so there are other parts of this page that are actually rendered from the data that was generated with the SVG. If you scroll down a little lower, correct?
Yeah, legend.
Is actually rendered from data that we generated in the SVG.
Yeah.
Because the SVG it's almost like a DOM object. Even though we think it is.
Oh yeah, that's a good point. Yeah, I guess I sort of take that for granted. Although I know it's not the case here, but SVG, yeah, it's basically no different than an HTML element, so you can do all kinds of cool stuff with it. So yeah.
Cool. Any last questions?
Once.
All right. Let's give it up for Brad.
All right. Thanks.